Hey everybody, how you doing? I just wanted to, I know I gave you guys the polyatomic ion list, and I just want to just make a quick screencast here about what we do with polyatomic ions. Okay, so just really quickly, we draw this out a little bit. Check out my lines here. Um, Polyatomic ion, basically a polyatomic ions. Okay, so we know what's going on and make it's a little bit thinner here. Okay, if we take a look at the word polyatomic ion, you'll see there's really two words here: poly, okay, which means many, okay, and atomic means atom, okay, and ion means charge. It's a charged particle. Okay, so a quick background: if you have just a regular ion, say as a chloride ion with a -1, that -1 simply means you have one extra electron. So an ion always is charged because it's got this little minus. If it was -2, it would be with two extra electrons. If it was -3, it had three extra electrons, and so on. So when you have so this would be called a monatomic ion. Mono meaning one, atomic meaning meaning atom. Okay, and you'd represent this as a little, as a little atom with a little minus sign. Okay, when you have a polyatomic ion, okay, these are groups that have a charge. Okay, so if you look at your polyatomic ion list that I gave you, I use the example of carbonate. So carbonate would be CO3 with a -2. Okay, and the name of this is called carbon 8. Okay. Okay. Now, of course, you see the carbon, which is there. Okay. And this part right here, this 8 part, is really the oxygen. Okay, section. So we call this carbon 8. Now, what does this really look like? This looks like a carbon atom. Okay, so you have your little carbon atom, and then you have 3 oxygens that go around it that are attached to it. So that makes this like a little family. Sometimes we call it a family, and that goes everywhere together. That stays attached. Okay, and in this is 2 extra electrons. Okay, so you don't know why they're there, or I just want you to know that they're there. They serve a purpose. Okay, so you have this group. Okay, and there are many like this. Okay, so just understand that this -2, okay, goes for the entire thing. This -2 goes for the whole thing. These are at this point we're going to say that they can't be separated. They really can be later on, but these are families that are very stay tightly. So, for example, other ones. The nitrate ion would be NO3 minus. Okay, the phosphate ion would be 3 minus for the whole thing. But again, these are groups that have charges. All right, so I want you to memorize this list. I just wanted to give you a quick explanation of what a polyatomic ion is, okay, versus a regular monatomic ion. Another monatomic ion would be the sodium ion, which would be +1. But again, it would only be one atom, where the polyatomic ions have groups of atoms that have charges that they stay together. So I want you to know these as separate particles. And lastly, when you look at something like, you look at a compound like sodium and carbonate, you want to realize that you're not looking at 3 separate elements here. You're looking at 2 pieces. You're looking at the sodium part and then the carbonate part. You're not thinking of these as being 2 separate elements. You're looking at them as a group. Okay? All right, so that should do it. And then we'll end it here, and that'll be it. Okay? Have a good day.